Okay, so now we're going to cover how to subset data in R. This is pretty important. Most analyses involve some form of subsetting, whether it's rows or columns. And so using in class yesterday and a little bit in the lab this morning, we showed one way how to read in data using read_CSV or read.csv. In this module, we're going to talk about how to select specific elements of an object by an index or some sort of logical condition. And then we're going to use that to subset rows of a data frame. We're also going to talk about how to subset columns of a data frame, how to make new columns or remove columns, how to reorder columns, and how to reorder rows. And so here, for the sake of just historic purposes, there's two ways of sort of doing a lot of this stuff now. There's a new package called dplyr, just like there's sort of a read.csv and a read_CSV. They've made sort of new syntax for selecting things, rows and columns. dplyr, it's definitely easier to use if you don't come from any background. It's supposed to be more intuitive, I would say. However, just like because it's so new, there's less material online that helps you. So for a lot of these slides, I'm going to show how to do it in base R and then show how to do it in dplyr. It's one of those things where you'll play around with both and sort of pick what ultimately feels better for you. There's a few documents here that gives you some information on getting started with dplyr. It also interfaces well with Tibbles, so the same person who wrote read_CSV with the reader package also wrote dplyr, Hadley Wickham. And so this is sort of what I'm going to go through is sort of a very brief introduction. Some of these resources might be a little bit better and go into more detail. This is not sort of a conclusive list. There's a ton of material out there that'll help better teach dplyr. And Jeff's going to have a few slides on that too, and some of the summarization slides. But again, I'm just keeping both base and dplyr just so you get exposed to both and then can make an informed decision on what you like best. And so subsetting data, you can select specific elements using brackets, square brackets. And so if I have this vector of numbers 1, 4, 2, 8, and 10, it's a length 5 vector. If I say x bracket 2, it returns the second element of this particular vector. And so that's the syntax in base R. And so with dplyr really only works on data frames or things like data frames. There's really no one-dimensional equivalent to it. And so anytime you have vectors, you have to use this bracket notation. So maybe I want to select the fifth element. They say x bracket 5. That returns 10. And you can also select multiple elements at the same time. So I'm going to collect the indices 2 and 5 and use that to subset my vector. So now you get a length 2 vector return. That's 2 and 10. So this is a little bit, if you haven't seen this before, it's a little bit confusing, but just realize that you're basically telling it what slots to extract from. You can give it as many slots as you want with this particular collecting command. There's other ways you can do things by subsetting via deletion of elements. You can put a minus sign before an integer in a bracket. That'll basically return all but that index. So if I'm going to say x minus 2, it's just going to drop the second element and return everything else. You do have to be a little bit careful with the syntax when you want to drop more than one element. You want to say minus, I'm going to collect 1, 2, and 3. So this is going to return elements 4 and 5. You can make sequences using the colon. So if I say 1 colon 3, that's the same thing as 1, 2, and 3. If I say I want to subset from minus 1 to 3, you get an error. You see that R thinks this is going from minus 1 to 3, and it doesn't know how to subset based on minus 1. So you would need something like parentheses here. These two things are identical. This is just shorthanded. If you want to just take the first 100, you just say 1 colon 100 instead of typing 1, 2, 3, 4, etc. But most of the time, you're not going to end up just selecting individual elements. You want to basically use the data to tell you what elements to select. So if I still have that vector x, which is 1, 2, 4, 8, and 10, this is where the logical class comes in. So if I say x greater than 2, it's going to return a logical class that tests that condition to every single element. So it's going to say, is 1 greater than 2 false? Is 2 greater than 2 false? Is 4 greater than 2 true? Is 8 greater than 2 true? Is 10 greater than 2 true? So now you have 2 falses and 3 trues, and then you can subset based on these logical conditions. So when you subset based on a logical, it'll only return the elements that are true. And so here it's saying x bracket x greater than 2, close bracket, so it'll return 4, 8, and 10. And so this is, again, where you're using the data to help select. You don't need to know, I don't know that the third, fourth, and fifth ones are greater than 2 before I run this command, but it just lets you use the data to pick out which elements to remove or to extract from the data set. There's ways of chaining together these logical statements. The ampersand is the and the pipe, which is shift, backslash, is it's above the enter key on most keyboards. The pipe is the or. So if I want to take x and subset it by those elements that are greater than 2 and less than 5, it's only going to take the 4. And so it'll return, it'll be false, false, true, false, false, and then it'll subset based on that. If I want to say x greater than 5 or x is equals to 2, note the double equal sign is used for logical testing, not the single equals, which is assignment. And so here it'll return 2, 8, and 10. These numbers fulfill these logical conditions. And so another way of subsetting, instead of just taking trues and falses, the which function is really useful here. Which takes a logical vector, and then it gives you the indices that correspond to true. So if I say which x greater than 5 or x equals 2, the second element was true, the fourth element was true, and the fifth element was true. This just lets you subset in a slightly different way. This is nicer when you have some missing data because it drops missing data, as we'll come to in some of the data cleaning. Note you'll get the same results almost all the time unless you have missing data. It's just a different way of just adding an explicit call to take the indices that it corresponds with instead of using a logical vector. So let's just make a little toy data frame so you can see how this works in, sort of in two-dimensional space. I'm just going to make this, I'm going to collect a vector. This is just a little shorthanded notation for just sampling random numbers. So I'm taking 5 random Poisson variables, 5 random normal variables, and 5 random Poisson variables. And so let me just run this. And in R, this is an important side note. Anything you do with random number generation or sampling, if you don't do this command called set.seed and put some random number that specifies, or some number that you designate that sets the seed, you won't be able to exactly reproduce the random numbers by which you've sampled. So anytime I run R, if I were to type set.seed 2016 and run this command, you'll always get the same data frame. If I don't type set.seed, every time I run that, I'll get a different data frame. So for example, so here I'm saying if I run this with set.seed, so now if I don't say set.seed, the first column is the same because it's just sort of hard-coded as numbers. Then you'll see that the values for x2 are different, for y are different, and for z are different. However, if you reset the seed by saying set.seed, you'll get back the original data frame that we're using for this example. So the key is if you say set.seed, anytime you do sampling, if you want your sampling to be reproducible, you have to include some kind of command like set.seed at the very top of your script. Okay, so this is the data frame we're using. It's a 5-row by 4-column data frame. And so just like we just showed, if you want to rename columns, you can say columns of the data frame called df. I'm collecting lowercase x, capital X, y, and z. Note that the data itself never changes. These are just attributes of the data. And so you can see it's really easy to change the column names. I'm just going to reset it for the sake of other slides. So this is something where you can change it. You can change it back really easily without having to say reread in the data frame or regenerate the data frame.
I have a question about column names.
Yep.
In the exercise in the lab that we were just doing, if you wanted to rename just one column, I saw how you could subset and call on the position of that column. But sometimes it makes me nervous, calling a position, what if you miscount or something? So is there a way to rename it, calling the current name of the column?
Yeah. So one way you can do that is you can set a vector of the column names. You can say which of the column names is equal to something, and then change it, and then reassign the column names based on that vector.
Okay.
So that's there's also ways of finding patterns in strings, or as I'll cover here at the end, you can say starts with or ends with a certain string. So you could also do this in one. This is probably the easiest way. Some sort of checking for which columns are equal to some column names are equal to some value, and then changing only those. But yeah, I agree. If you just say the numbers of by which you want to change, if someone like gives you a slightly new data set where everything's shifted, it's going to mess you up, and that happens a lot. So it is usually much safer to not use actual numbers to do subsetting, to actually use the values of the data, whether it's the names of the columns or the actual values of the data. I mean, sometimes shorthanded for like the sake of this, I'll just type :1,5 and like do it that way. But in practice, unless you really know the data set that you're working on, that you should be careful doing that. So again, what this is doing, I'm saying I'm making a new vector. So again, note that running something like this. So this vector has now nothing to do with the df data frame. It's a completely separate R object. There's no link beyond the fact that you pulled it out of that object. So if you change the CN, it won't change anything related to df. They're totally, unlike other languages where there's sort of, you can only have one data set in your workspace at one time. R is not like that. So this is, again, totally has nothing to do with the data frame anymore. Just the fact that you extracted it from there. So then I'm saying I'm doing a logical test. So what this is looking like, if I'm going to break this down a little bit more, this is saying which of these values, so okay, it's taking x, x2, y, and z. I'm logically testing which ones are equal to x2. I'm subsetting this vector of what are column names by whichever values are equal to x2. And then the last line is it's overwriting the column by which that statement is true. And then you're reassigning. Then now you've cleaned up these column names, you're going to reattach it to the data frame. And that's what this is doing. So that's sort of a few things happening in one line, and that's sort of what makes R useful, but also a little bit complicated, just because there's kind of a lot going on here. It's sort of working from taking this variable, logical test, subset, reassign, all in one shot. And again, I'm going to reset the column names for the sake of the next slides. And so now that's base R. So now for dplyr, if you want to rename columns. So sometimes when you read in some of these packages, what you'll see is you'll get a bunch of red text that says a bunch of stuff. Sometimes some of the text says that certain function has been masked from your workspace. Oops. So for example, so then you'll see this text. And so what's happening is dplyr has functions called intersect, set, diff, and union. Lubridate also has functions called intersect, set, diff, union. Lubridate was already in my workspace, and so now when I say dplyr, whatever R thought those three functions were, they now are whatever was in dplyr, because it's sort of the last thing that you've read that you've initiated. Same with base level stats for filter and lag, and base, intersect, set, diff, set equal, and union. So that's just sometimes two functions might have the same named functions, but it'll always take priority to whatever you loaded last. Or if you wrote a function called union and then you ran it after this command, it would overwrite whatever was in your workspace. So for example, if I want to just look what filter was, say like I didn't know which filter was better. Now filters just use method filter. So now one way to do that is you can actually explicitly designate a namespace : package. And so you can see exactly where it comes from when you run filter. This just helps you get a sense of it. It's definitely using the dplyr version of filter, not the stats version of filter. However, if you want to explicitly use the stats one in the same function, the same script, for example, we're using dplyr, you can use these double colon operators that says package : function. So now if I want to use the stats version of filter, you can see that it's totally different compared to the one in dplyr, even though it has the same name. So this is one way of designating explicit functions when they tend to have the same name as other functions in your workspace. So now just to do this with dplyr, you can say dplyr. So the rename function in dplyr is what the key is here. And so you would say rename, the name of the data frame, comma, different columns that you want to rename. So what this is doing is it's overwriting the data frame. So now df is a data frame. I'm saying capital X is what you should rename the former column of x2 to be. right? So then it's saying whatever was x2 now becomes x. So it's sort of like one line in dplyr. It's pretty easy. If I wanted to rename columns x2 and y, I would say x equals x2, capital Y equals lowercase y, and then you would get 2 columns renamed instead of just one. Again, if I just want to reset it, I can just say rename data frame. Now I want to say whatever column was capital X, I want to make it x2. So it's really easy to go back and forth. You just need to know the name of the column, and then you would just pass whatever you want the new name to be within this rename function. Are there any questions? Yep.
When I use this function, do I have to transfer like a matrix or table into a data frame?
dplyr matrix, it won't. You need to have a data frame for dplyr. It works well on data frames. You might be able to do some functionality with matrices, but it was really meant for data frames or tables or things like a data frame where the columns have explicit names. I'm not sure how well someone would work with matrices, but again, they're mostly designed for data frames. Yep.
For this like rename function versus taking the base arc approach, which one is faster?
Faster, it's usually super fast because the names are usually a fixed attribute. I mean, it's usually pretty short relative to the size of the data. I don't know personally which one's faster. It's more the syntax that's a little bit different. So now let's subset some columns with data frame. If I have a data frame, I say data frame $ column name. So for example, if I want to extract the column called X, I say df $x. And that gets returned as a numeric vector, not as a data frame anymore. You can also subset data frames with the bracket notation, just like you can subset single one-dimensional vectors with brackets. I can say now there's 2 slots that you would use. It goes bracket rows, comma columns, close bracket. So if you want to grab the first column of the data frame, or this also works for matrices, you can say bracket nothing, comma 1. This means take all rows and just the first column. You can also use names that are in in strings, in quotation marks. And so this would say take the column of df that matches the name x. These are 3 ways of extracting data in this pretty much the same way. Either df $x, df bracket comma 1, df bracket comma x in quotation marks. If you want to select multiple columns, you can either collect the names of the columns you want to extract, which is safer. You can also pass just a string of numbers that extracts each of those elements. And so now if I want to take all the rows and columns X and Y, you would run something like this. Note if you put numbers to the left of this comma, it'll only take those rows. So if I say df 1 to 3, so you can also do a mixture of I only want some rows and I only want some columns. That's one way to do that. The equivalent to do this in dplyr is the select function. And so I would say select the name of the data frame, comma, which columns you want to select. And so I'm going to say select df, comma x, and that just extracts the column named x. If you want to subset multiple columns, you can say select the name of the data frame, comma, then anything you type, those will all get selected. You don't need to collect anything. You just tell it in order, separated by commas, which columns to extract. There's a few helper functions in dplyr called starts with or ends with. So it's going to take any column name that starts with an X string, and then it'll try to do a little bit of pattern matching, which we'll come back to this afternoon, to give you X and X2. This is just useful if you have 15 columns named date or visit number. You would just say starts with visit number, and that would extract all of those without having to type visit 1, visit 2, visit 3, etc. So that's pretty useful. Are there any questions about that? Yep.
Sort of the opposite way, can you like drop certain columns?
Yeah, so I could say, I believe you just do this. You just put a minus sign just like you can in base R. You just put a minus sign. I don't think there's a contains version of it, but again, you can use some string matching that will cover how to do that in a little more detail. So subsetting rows, just like subsetting columns, I can take rows. Oh, sorry, do you have a question? Nope, okay. So here if I just want to take the first and the third row, I say data frame, I put all the indices to the left of the comma, I say take 1 and 3, comma, all of the columns. And so that is sort of the converse. So it's just taking the first and the third row and all of the columns. And this is what you'll mostly do for subsetting. You'll basically use the values of columns to subset rows. So I'm saying let's subset this data frame such that the x column is greater than 5 or the x column is equal to 2, comma, and then all of the columns. And so that's taking 2, 10, and 10, and then all the data from the rest of the rows worth of data for those particular observations. Again, you can also mix and match row into subsetting and column into subsetting. This is taking those rows where x is greater than 5 or equal to 2. We only want to return columns y and z. This, again, mixes both subsetting rows and subsetting columns just for some more flexibility. And so the equivalent dplyr is using the filter command. And so filter, again, you give it the name of the data frame, then you provide the corresponding logical conditions that you want to filter by. You don't need the $sign, you don't need subsetting. R knows that x refers to a column of this particular data frame. And so again, you would just say, I want to filter this data frame by which the column x is greater than 5 or column x is equal to 2. And again, it returns the same exact output. Again, so it depends on if you like base R or dplyr. It's more like what you feel more comfortable looking at or which makes more intuitive sense to you in terms of how you think about subsetting data. And so here you can also chain together multiple filter commands. You can separate conditions by commas. And if you separate it by commas, it just assumes that you're chaining it together with an AND statement. So if I want to take those rows where x is greater than 2 and y is greater than 0, you can say filter df x greater than 2 and y less than 0. Or you can just say filter x greater than 2, comma, y less than 0. So you don't need to chain together with ands. You can just separate them by commas. Again, that depends if it makes more sense to you. So it's like with this data frame, do this, then do this, then do this.
Is there an OR operator for the filter?
No, so here's you have to be explicit here. You would have to say x greater than 2 or y less than 0. So then if you want to take rows and columns, this you would have to use select. You would apply filter to the data frame. So R kind of works middle out. So you would say filter data frame, x greater than 2 and y less than 0, or this could be a comma. And then to the output, I'm going to select columns corresponding to y and z. And so again, you get back the correct, what you expect. And so in R, the common ways to perform multiple operations, kind of just wrap the functions around each other. You could also create temporary variables and reassign them. So let's just take let's make a new data frame where I take only those rows where x is greater than 2 and y is less than 0. Then to that data frame, I select only columns y and z. That'll give you the same thing. However, there's a newer way to do this called piping. So if you're familiar with Linux, you might be familiar with the concept of piping, where you basically take output and stream it to the next function or task without actually saving any intermediary files. And so that is percent less than percent. I believe it's Control-Shift-M if you're just typing an R Markdown document or an R script within RStudio. And so what this is doing is you say, with data frame, pass it to filter, and then take its rows such that x is greater than 2 and y is less than 0, then pipe that output to the select function and only take columns y and z. And so then you don't actually have to type the name of the data frame again. You just say df. So say with this data frame, filter the rows, then select the columns. And so you would need piping to the filtering, then piping to the selecting, and this will return that particular data frame. So again, this is pretty intuitive. It's a little bit more easier to read. Instead of like reading from the middle out to these series of functions, you're reading from left to right. And so this is something that's become pretty popular. And again, this plays really well with dplyr. Are there any questions on this? Jeff's going to use this a lot more in some of his slides, and some of these slides are also going to use this. So again, just it's saying with this, do this, then do this.
I'll go over this pretty carefully, so this is seeming a little bit like fast. He's giving you the first look at it, and you'll see again a more
Let's just go over adding rows and columns. So if I want to add a new column in BaseR, you can just make a variable called newCol to data frame. I could use the bracket operator. I'll say df $new column. It'll be the sequence from 5 to 1, so 5, 4, 3, 2, 1. Or you can make a new column based on values of an existing column. I could say df $new column is whatever values were of column X, just add 2 to them. And so this will And so now the new column gets added. You can see there's now in the data field in your environment. Now it has 5 variables instead of 4 variables. And so now you've changed the underlying data. You can remove a column with the null. You'll note like true or false. It's not in green. It's not quotation encapsulated. I would say df $new column equals null. Or you can select only those columns that were not equal to new col. So here I'm taking the data frame, I'm subsetting it, taking all rows, and doing a logical test of saying, are the column names not equal to new col? So it's going to say true, 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 false, and then only take those columns that were true. So if I run this, you'll note that now the data has changed. It says 5 observations of 4 variables, and I've removed the new column from my particular data frame. Another way to do this is with the C or column bind function. This allows me to bind a data frame, some new vectors to a data frame, or lets me bind 2 vectors together, or 2 major C's together, or 2 data frames together. This is just the general syntax. This only works if the thing you're binding is the same length as the thing that you're binding to. Sometimes you'll get either a warning or an error depending on what you try to do. So this one's not recommended, but it's just making you might see this as a solution online somewhere. And so with dplyr, the key function here is mutate. And so with mutate, I'm going to say mutate the name of the data frame. The new column is going to be called new col. It's going to be 5 to 1. You can see that it just returns the full data frame when you've added this particular column. We don't actually need this print call. It's going to print either way. But this is the equivalent here is I'm going to overwrite df and say df mutate df. New column is equal to x plus 2. So it finds the x column of df, adds 2 to it, then assigns it to a new column called new col.
Why are the curly brackets needed there?
Yeah, this was an older set. They're actually not needed, but it's sometimes if you run multiple lines of code, they're needed for this printing command. But I can change this slide and update it. And so if you want to remove columns, it's pretty easy. Although the null method is common, you can use like the minus operator with the select, like we just talked about. If I wanted to remove the column I created called new col, I can say select df, comma, minus new col, then it'll return the data frame without that column anymore. So that's a pretty easy way to do it as well. And so this is the same way of doing it, just with slightly different syntax. And so instead of saying minus new col, comma, minus y, you can just say one. There's a one of function that is a helper function dplyr. That's how you could do it as well. So say I want to change the ordering of my columns. This is an example where I want to say, let's put the new col first, and then the rest of the columns after. One way you can do that is you can just assign the column names to a new variable, cn, and then I'm going to collect new col, and then the remaining column names that are not equal to new col. So that basically moves that column from the last column to the first column and keeps the rest of them in order after that. Again, this is good because you don't need to know exactly the indices by which you're shifting around. You could have gotten the same result by saying C5, comma 1 to 4, but then if your data changes and those columns aren't 1 to 5 anymore, that gets a little bit risky. It's a lot easier to do this in dplyr. You can just say select new col, then if you apply the everything function, which is built into dplyr, it just takes the remaining columns in the original order. So this might be a little bit more intuitive. If I want to order rows, say I want to order rows by the value of some column. If I take the data frame and I say data frame order the x column. In this case, it goes in increasing order by default. from smallest to largest, and then I'm saying comma, and then take all the columns. So now what gets returned is a new data frame that has, again, is in order of the X column. And because you've done it with this comma, it basically just keeps all the columns that you had in the original data frame. You can also say decreasing equals true. So instead of doing ascending order, it does descending order. So now it just starts with 10, 10, 4, 2, and 1. And so what you can also do is you can pass multiple vectors. So if there's ties, you can give it like a tie-breaking variable, for example. And you can also make one being ascending order, then one descending order. And so now if there's a tie, it's taking the highest value of y in this case. So if x is equal, it doesn't know how to separate the fourth and the fifth. So now it's using the column y as a tiebreaker. So it's saying sort by x column first, then for ties, sort by y. In dplyr, the equivalent function is called arrange. So I say arrange data frame comma x. It's going to, by default, put the rows in an ascending order, just like order. And so this is the equivalent of the df bracket order, comma, bracket. This might be a little bit more intuitive. You don't need to know brackets. You don't need to know the order function. You can just use arrange df comma x. And if you want to put it in descending order, you just apply the descending function to x. And so you would say df comma descending of x. And that just switches, instead of ascending order, it becomes descending order.
That's a great question.
Yep.
Does order also work alphabetically?
Yeah, it's alphanumeric by default on a character string. So it'll do like the numbers first, then letters. And so, for example, here, if I want to arrange the data frame by x and then tiebreak by descending y, this is the equivalent version of dplyr. So again, so it just looks a little bit nicer than using the sort of the base R subsetting, but it's doing the exact same thing. And again, it's something where you can decide what you like or you feel more comfortable looking at. Lastly, the transmute function in dplyr combines both mutate and select. So you can create new columns and keep only those columns that you want. So that's saying transmute. Let's take this data frame. The new column 2 is going to is a function of x times 3. And once I apply this, I'm going to also retain columns x and y. That's like just instead of saying mutate, pipe, select on the data frame, this is just sort of a one-shot way of creating a new column and only returning the columns that you want. And so with that, I think it's right in time for break. There's a lab associated with this. We can go through it quickly after the break, and then Jeff's going to move into advanced data I/O. And then after lunch, we'll cover data cleaning and also
A little bit more, like
more of this string. Yeah, that's right.